This is Dr. Carroll, and this video is about multi-dimensional arrays. So let's start off with two-dimensional arrays. So you want to store something in more than one dimension, probably because the data itself lends it to that, and so indexing into one dimension and then another dimension makes a lot of sense. So let's look at the syntax. A lot of this is the same. The difference is here, the data type has changed, not from data type brackets to data type brackets. Brackets to indicate we have an array of arrays. And so we would declare this by saying, hey, we need a new data type with this many row elements and this many column elements. Now, to be clear here, Java doesn't care which one is rows and columns so long as you care. And almost always we do rows then columns. So follow that convention unless you have a really good reason not to, and you document it throughout your code. So go row, columns. And that's how we declare a new array. Now, you might already know all of the values that you want to set in your array, so then you would just, you could be able to initialize them. Now notice the order here. We have two sets of braces, curly braces here. So the outer one is for the outer array, and then the inner one is for the inner array, or you could think the second index. So the number of braces at this level, so 1, 2, indicates that we're only going to have two elements in this first index, whereas we might have 1, 2, 3 or more. It doesn't have to be a rectangular array, would be for the second index of the first index. Sorry, the second index, but of the very first array in there. And so that's how we declare them. Let's look at an example here. You may be familiar with the game of checkers. So checkers has an 8x8 board here, and it's initialized by having black pieces and alternating positions for 3 rows, and we have red pieces. And so if we think of a checkers board, an 8x8 board, as having strings in it, and the strings either having a space, an R, or a B, then we'll get something along these lines here. And so let's look at this simple class to illustrate this. So we've set the size of the board to be 8. That should not change unless you're changing the definition of checkers. And then we have this board here that is private, or we can make it public if we wanted to share that board. And we have a constructor here, and this comment here indicates what it's going to look like when we're done with the following code. So let's look at this code. So we are creating a new two-dimensional array here, an 8x8 board of strings, and we're assigning it to this array of array references named board. Now notice how we can initialize each square to space. Now we don't need every square to be space because we're going to put R's here, but it's just so much easier to do them all and then go back in and put in the R's and the B's. So we go through each row, we go through each column, and we assign them a space. Notice the syntax here. Just as before, we are getting this index out of this array here, the board row. And so it's really an array of an arrays is what a two-dimensional array is in Java. It's not an inherent two-dimensional array. Okay, now that we have a space in every one, let's put in the R's for red. And so we start at, we're saying row 0, and the orientation is up to us to keep it straight. And in fact, anybody using the checker class doesn't have to know, I guess they do. We could have changed it and mapped it if we wanted to internally to have an external version, but in this case I actually require, as you'll see later. So we have a board that has row and columns, so 0 and 1, and then we increase the column by 2. So what we did is we've just set this one and then we've advanced column to 3 here, and we put in all of row 0 reds. We increment row, set column to 0, do the exact same thing, increment column to 1, and then do the exact same thing. Maybe we could have put that in a for loop with a little bit of logic. Very similar, except we start the row back 3 from the end, and then we put them in. We have a display board here. Notice very, very similar code to how we initialized it. We're going to go through each row, and for each row we're going to go through the column, and we're going to just display that board. It's going to be a space or red or blue, and then at each row, notice we have a nested for loop. At each row we're going to put in a new line here. So this will be a space or red or B, 8 of them, and then we'll put in a new line. Get location here is just going to access into that board and return it. So let's look at main here. So we declare a new checkers game, which is going to populate that board. We're asking the game to display itself, and then we're just pulling out the second row, third column, and then second row, fourth column, just to see what that is. Let's compile this and see what happened. Woohoo! It compiles. Now let's see it run. Make it a little bigger, make it a little easier to see here. Yep, sure enough, red, 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 blue, blue, black, 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 black. Notice it's inversed from how it's displayed just because how the comment was oriented. And then row 1, so the second row, third column, 0, 1, 2 is R, and then the one next to it is a space. And there we have an example of a two-dimensional array. So now let's look at multi-dimensional arrays. So it's a lot of the same, we just keep adding on braces, square braces here. So let's look at an example of airline prices to see this. So here we have a simple example, and I just put it all in main. I've hard-coded some indices here, Columbus, Atlanta, and we're keeping track of the number of rows here. And we have this array cities. It's a string array, and we put in Columbus and Atlanta here. Notice we didn't have to call new because it knows how many are in there. And then hard-coded the indices for Thursday, Friday, Saturday, and put in Thursday, Friday, Saturday into another array. And then we want to keep track of airfares that our first index is going to be the city from. The next one's going to be the to city. And so notice what we did. We just tied it to the length here of cities. And so that way, if we add in a city, we automatically create a larger array for doing this, for both the to and the from. Then the third index here is which day, and so if we considered adding in a Wednesday, for example, of flying, then that would automatically increase the length here. So I've just hard-coded some prices I pulled from the internet. So flying from Columbus to Atlanta on Thursday was $236.98. On Friday, a little bit more. On Saturday, a lot less. And then coming back Thursday, Friday, Saturday. And so now, here's some interesting code. Let's calculate the minimum price over everything in the array. And so to do that, we need something to compare it to say, hey, have we found the minimum price? Now, when we can't use 0 because that won't work because nothing will be smaller than it. And we can't just use a really large number because what if the prices exceed that? So maybe we could have used max double, that would have worked. But alternatively, what I did here is I just used the first valid price. And so from Columbus to Atlanta on Thursday. Notice we didn't populate Columbus to Columbus on Thursday. And so that is going to default to 0. So truth be told, I actually did that and then realized it was wrong, but I won't even mention that. Okay, so let's see here. Now we're going to go through and we're going to display all valid combination of flights. So we're going to have this from index, and notice the continuation criterion for each of the loops. It's a three-dimensional array, so we're going to have 3 for loops to iterate over all of it to display all of it. And while we're displaying it, we're also going to look for the lowest price. So notice this first one is how many elements are in the outermost array. That's our from index. Then in the from index, we say how many elements are in the array for our from index. And then we say, hey, if the flight is, the departure and the arrival cities are the same, that's pointless. So just skip over this one. Don't even go through all the days. So now the continuation criterion is from this index to this index, how many days do we have? And that's by length. Now this could have been a jagged or ragged array. It's not in this case, but it could have been, and so this protects us from accessing elements that we shouldn't. And so we just display from the city to the city, and then notice here the airfare is just one index, second index, third index into the array. And if we want to see if then we check if this price is lower than a minimum price, and if it is, we set minimum price. And then we're just going to display the lowest cost. Let's compile this. Nope. Airline prices. Woohoo! It compiles. So remember, we were displaying each of them from a city to a city on a day, and then we pulled it out. And then when we were going through all of these, we kept track of looking for the lowest price, and sure enough, from Columbus to Atlanta on a Saturday happened to be the lowest price. Now, often when we're keeping track of the lowest price, we also want to keep track of where was that. So we could have kept track of the lowest index from, the lowest index to, and the lowest day index as well. But we didn't, but that suffices. I hope you enjoyed it. That's it for this video.